Good evening. Gabi na. From drawing to assembling the actual components into this. So the proof of concept is almost done. Let's fire her up tomorrow. And let's see the result. Okay, so just want to share the conversation with Grok AI. I'm very biased to these using this AI because, well, it is created by no one else but Elon Musk AI X AI team. That's why it's very enthusiastic and it's very fun to use. And I think it's very beneficial to researchers, innovators, and engineers that has the interest to change the world or making life better. So let me share the conversation with Grok here. This is still in connection with the device that I'm trying to create. First, to address the issue of salt supply domestically in the Philippines, and at the same time to create potable water or fresh water as a byproduct. Actually, we're hitting two birds in one stone here, basically. So, yeah, I must admit, I've been using AI to consult or ask inputs on how to create this device. But the key actually here is even you use AI, if you do not ask the right question, you would not get the desirable result. So hopefully this prototype or proof of concept that I'm creating would work eventually. So I'll be testing this tomorrow. So let me share the conversation with Grok here. Of course, we had conversations previously, and I said, "Hey Grok, it's me again." And Grok responded, "Hey Samo, what's good, my dude? Back for more chaos or something specific on your mind?" So I said, "Remember our last convo related to the plan to build a portable vacuum desalination kit?" And Grok said, "Yes, I remember. We were brainstorming a portable vacuum desalination kit, something compact, maybe solar assisted or low energy, that uses reduced pressure to evaporate seawater or lower temperature for easier distillation into fresh water. Smart idea for survival, camping, boating, or off grid use in places like the Philippines. Let's pick up from there and refine it." So, quick refresher of why vacuum helps. Water boils at 100 degrees Celsius at sea level or 1 atmospheric pressure. So, this is the normal evaporation we observed at sea level. No? That water boils at 100 degrees Celsius always. Under vacuum, the boiling point drops dramatically because there's less atmospheric pressure pushing down on the liquid surface. At 0.023 bar or negative 17.5 torricelli, water boils around just 20 degrees Celsius at room temperature. Imagine the benefit. But of course, achieving this very low pressure would be challenging as well. At zero point 0.1 to zero point 0.3 negative rather bar, it boils around 40 to 60 degrees Celsius. So compared to 100 degrees Celsius, this is significant difference. Much easier to achieve with mild solar heating or waste heat. This makes evaporation feasible without intense heat source, reducing energy needs compared to traditional boiling distillation. Vapor then condenses elsewhere into clean water, leaving salt behind. So that's the goal when we're trying to achieve a quick or faster way to cook salt. So we'll be creating a machine that going to be assisted by a vacuum pressure. So in that way, water will evaporate rather faster and would not need much heat to obviously evaporate the salt water to produce salt afterwards. So his or her insight is core components for portable version. So since I'm just creating a proof of concept, building a on typical DIY or survival design and vacuum principle. So this is also another idea that I'm planning to create a portable vacuum desalination or portable freshwater generator for camping purposes or outdoor activity purposes. For example, you would go into a remote say area for camping or just outdoor activity, whatever. You don't need to bring a lot of container to bring potable water, so you just need this portable kit, and you just create a heat source on site and then bring out this portable desalination kit or freshwater generator machine, then you have water. So it says evaporation chamber, a sealed sturdy container, example modified stainless steel bottle, pressure cooker or custom acrylic glass chamber that can hold vacuum, add seawater inside. So yeah. Number two is vacuum source, hand pump or small electric vacuum pump like 12 volts, like those for brake bleeding or food preservation. So that's actually what I purchased recently, the brake vacuum bleeder. It's just the small handheld pump, and maybe eventually we'll improve that into a more ideal capacity, in terms of volumetric efficiency or this extraction capacity. It should be sized properly. So anyway, it's just a proof of concept for now. Maybe undersized, but at least we can show the operation under negative pressure, or even natural vacuum setup using temperature or height difference. Maintaining the seal is key, sabi niya. So use O-rings or gasket and valves. Heat input, it can be solar or black absorber surface, flexible lens or parabolic reflector or concentrations, or low power electric heater. Aim for gentle warming to 40 to 60 degrees Celsius under vacuum. So technically, it's achievable using just the sunlight to generate 40 to 60 degrees Celsius. But if you have other means to produce this amount of heat by, say, for example, burning a wood or any source of kind of biomass there when you're outdoors, so it's technically possible. And then the fourth component is the condenser. It's used to cold tube or surface, air-cooled fins or water cooled coil or passive radiator where vapor turns back into liquid. So again, based on the diagram that I have shown previously on my videos, so I have these components as well. Then of course to support to hold the components together. Simple DIY starting point inspired by survival bottle kits. Use a sturdy plastic bottle as evaporator. Add a tube leading to a separate condenser bottle. Apply vacuum and mild heat. These produce small amount but prove the concept. For better output, look at solar vacuum membrane distillation or VMB ideas of multi-effect setups. Through these get more complex. So again, actually this concept existed in a industrial scale actually that apply the negative pressure to evaporate water faster. Feasibility and challenges for portable use. Pros: it lowers energy than RO, yeah, reverse osmosis pumps, no expensive membranes if using pure distillation or potentially solar only. So this is actually one of the greatest advantage, I should say. The cons and hurdles: vacuum maintenance, leak kills efficiency. Yes, obviously it is. So you need to make sure the vacuum lines or the vacuum system is airtight or leak tight. Real world air ingress and non condensable gases require a good pump and purging. Yeah, we understood this. Output rate: portable versions often yield liters per day, at best, not gallons. Great personal use, not both. Well, let's see. Energy: vacuum pump plus any active cooling still needs power. Battery, solar panel, whatever. I think we can create a system that would not need much energy. A passive natural vacuum design helps here. Material: corrosion from salt water must be food grade safe. That's right. So, the very least, at least SS304L, or the more sophisticated material would be SS316 or to duplex type stainless ang kailangan gamitin to mitigate the corrosion if you're going to use it for saltwater desalination. Scaling: MIT style portable units exist but use advanced electrodialysis ICP, not pure vacuum. Yeah. So I think as far as the proof of concept out there, this portable idea doesn't exist yet unless or until we make this happen. Realistic target: a backpack size unit producing 0.5 to 2 liters per hour under good sun depending on the design. So next step for your build: what did we discuss last time specifically? Material, size, target, power source, etc. Refresh me so I can tailor this better. Sometimes they forgot or they don't have the precise reference or to recall the previous conversation in a few days or a month. At least he still have the idea. In the meantime, prototype small, test with a major jar, hand vacuum pump or solar exposure. Measure, track vacuum level, use a gauge, temperature, and output. Safety, don't create implosion hazard. Well, it's very prone to implosion if you really lowers the pressure into very, very low. I mean, you're talking about negative 10 bar in that magnitude. Maybe there's tendency to implode, to shatter the vacuum container in this case. Safety, don't create implosion hazard. Use thick materials. Test with fresh water first. So in my case, I'm just using a crude design in the meantime. So I'll just be applying a mild negative pressure. So just to show the proof of concept. Got sketches or budget or specific constraints, etc. Weight less than 2 kilogram, no electricity. So that's actually one of the previous conversation that we had. Let's iterate. I'm here to help troubleshoot or suggest parts. What part do you want to dive into first? So I said I already procured and assembled the components for the first proof of concept for this. I'll show you the diagram and later the video for your inputs. Got it, Samuel. Sabi niya. Also in progress. You've already procured parts and assembled the first proof of concept. That's huge. I'm ready for the diagram right now, sabi niya. You can describe in details the material used, how everything is connected, chamber size, vacuum source, condenser. So it's very, very detailed. I mean, to be precise, eh, in engineering point of view, you have to size everything. I mean, all the components to run the numbers, obviously. But in the meantime, again, I'm just creating a crude prototype just to show the operation. So it says paste and ASI schematic diagram. So you can actually paste the diagram here so he can review and provide you inputs. Or if you can upload, share an image or link, I have the videos uploaded on my YouTube account and also Facebook accounts. I'll be showing later. Once I see the diagram, I can give you targeted feedback on potential weak points or seal, vacuum integrity, heat transfer, corrosion risk, yada yada. Safety issues, way to improve efficiency for the next iteration, measurements, critique test. After that, send video for running our performance too. Go ahead and share the diagram whenever you're ready. I'm all eyes. See, it's very enthusiastic. You're like speaking to someone who's very interested, same energy and same interest as yours. It's very fun to use. So here's the simple diagram I have. It uploaded on my X account, also in my YouTube account. Just now I have the components assembled and ready to test tomorrow. Got it, Shambles, I said. I'm ready to review your proof of concept design right away, since I can't directly pull image from your recent expos and YouTube uploads in real time. Please drop the direct link, yada yada. Quick thing that would help me analyze it first. So what's the evaporation chamber? Material, water jar, pressure cooker, whatever. Vacuum source and pump, yada yada. Okay, so all those. Then I uploaded a screenshot of the simple diagram that I uploaded on my Facebook account few days ago. It says, "Great channel. I've reviewed diagram for your post. It's solid first proof concept sketch. Vacuum distillation aimed at salt production and fresh water as byproduct. Quick breakdown on your diagram from handwritten layouts. Evaporator, yeah, yeah. And it says here, sabi niya, this follows the classic low pressure evaporation unit. Nice initiative trying it to the Philippine salt industry needs. Yeah, that's one of the purpose. Strength of this POC design, simple and portable, friendly, bottle-based evaporation. Yeah, that's actually the goal. It's crude design that technically anyone can build it with just any materials that is around and readily available. So it would not be as complicated as, constructing and reverse osmosis machine. So also in terms of cost, it's very practical in a magnitude of, I mean, a fraction of the cost against the reverse osmosis or any filtration that can convert salt water into fresh water. Potential issues and improvement for tomorrow's test study. Vacuum integrity, biggest risk. Yes, I know. But it's not as that risky if you just manage the pressure properly. So I cannot achieve this -2 to -0.3 bar yet. But let's give it a try tomorrow. Heat application, sabi niya, the goal is to use the sunlight. But in my case, I will be using a electric heater to make this demonstration quick and easy. Condenser effectiveness. Make sure the condenser is long enough, sabi. Safety, implosion risk, ganun pa rin. So, drops to maybe 50 to 100 ml per hour initially. Scale comes later. Yeah, I'm actually expecting maybe lower than this, but at least we can show the proof of concept. Test plan tomorrow. He recommend to dry vacuum test first, then fresh water run, then seawater run, and send a video. So I have here shown the picture, screenshot of the video I have created just now. So I said, noted on this group, these are the actual components that I have assembled, by the way. So it says, excellent work, Samuel. I carefully analyzed the photo and assembled prototype. This very solid proof of concept. Much better than many DIY attempts I've seen. It got the core elements right. What you built in summary, sabi, evaporation, clear glass bottle with a glass fitting screwed cell in the cup. Good choice for visibility. Yeah, that's actually one of my purpose. So would able to see the action of the boiling or evaporation inside the bottle. Vapor line, copper tubing with the bottle top, long arch, coiled condenser. Condenser, nice copper coil, good surface area. Yes, I understood that initially. Ending glass tube that dips into the plastic jar will be your freshwater collector, right? Vacuum source, it's a handheld pump, looks like a brake bleeder type. Yeah, it's right. With attached pressure gauge, this is a big plus. So we have idea how much negative pressure we're getting, right? Overall, compact, portable, and use readily available parts. Yes, it's a purpose. That's the purpose. Strong points: copper tubing plus coil. Excellent thermal conductivity for condensation, of course. You have gauge, critical for knowing your vacuum level. No? Glass bottle allows you to see the boiling vibration inside. Simple and cheap, perfect for iteration. Yes, you can easily modify it, knowing that the cost of getting these components are not that expensive. Important issues to fix before tomorrow's test. Again, see, he iterate the vacuum seal integrity, or again the glass bottle for safety. That's duly noted. Condenser cooling, collecting dar, recommend test, yada yada yada. Okay, so I'll perform all these insights or inputs that he recommends. Yes. Send a video. Yeah, I will send a video tomorrow. And said, thanks, Rock. I'm confident that this will work, especially with all your inputs. Can I post this conversation to my SOCMED media accounts tomorrow? So everyone would know how Grok AI is very reliable, essential, and critical inputs. The key is asking the right question. Every time this works, right? Yeah, so he allowed me. Then I'll show you the video later on to show the proof of concept. So yeah, hopefully this prototype or endeavor would work soon. So I'll keep you posted. Thank you.